This video is on lessons 4.8 and 4.9. It is the first video for the second half of Unit 4, which is in Flipbook B. So this is the first time you are going to hear of logarithms, and we call them logs for short. I don't know who made up this word. I don't know where it comes from, but you need to associate exponents with logarithms. That's why these two topics are together in one giant unit. As you recall, in the previous few weeks, we've been working with exponents. So we're going to start by, first of all, let me just explain what this sentence says. I'm going to just read, it says, exponential functions are of such importance to mathematics that their inverses, which you guys know how to do inverses, they are functions that reverse their action. So the opposite or reversing multiplication would be division, reversing addition, subtraction, reversing squaring, you square root, and so forth, are important themselves. These functions, known as logarithms, will be introduced in this lesson. So logarithms are the inverses of exponents. So we're going to take a look at, they filled this table in for you already, the function 2 to the x. So you agree that this is an exponential graph because the exponent is a variable, x. So they filled it in for you already. They just picked some random x's, they went from -3 to 3, plugged them in for x, and figured out what the y values would be. So now they want you to create a table for the inverse of 2 to the x. So you don't have to actually write the equation, you just have to plot the points that would be on the inverse of this graph. So you know that you just switch the x with the y. So the x would switch and be 1/8, and the y would turn into -3, and so forth. So 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. Now it says, what would be the first step to find an equation for this inverse algebraically? So you know the first step is to switch x with y. So they want you to actually do this first step and then stop. So if you take, I'm going to use y instead of f of x. So if you take the function y equals 2 to the x and you simply switch your x with your y, you're going to get x equals 2 to the y. So he is the inverse right here, x equals 2 to the y. Well, there is another way to write the inverse of an exponential function, and it is with logs. So the function y equals, and this is how you read this, log base b of x is the name we give for the inverse of an exponential. So if you want to make a little note to yourself, the inverse of an exponential equals log. Like that's what it is, okay? So this is also the inverse. So in other words, here's how we can write an equivalent exponential equation using the inverse of an exponential. We know that this right here, log base 2 of x, would be the inverse of y equals 2 to the x, but we also know another way to write that inverse by switching x with y. So what that means is you can take the log form and you can write it in exponential form in this way. So pay attention. You have to know how to go from one form to the other because they're going to give you the question in log form, and you have to then turn it into exponential form because we know how to work with exponents. So basically, it's just another way to write it. So the number down here, the little one, that's your base. And you know where the base is in an exponent. It is the big number that is next to the little exponent. So you're going to take whatever the little number is in the log, and it becomes the base, the big number. The exponent that you raise the base to is on the other side of the equal sign. And then you set that equal to whatever this big number is next to the base. Okay, next to the log. So you're going to have to convert from log form to exponential form to solve because your calculator it can do this, but it's going to take a little bit of work to do this. And sometimes the calculator only will calculate logs if it's a base of 10. It won't do it if it's a different base. So you have to know how to convert these into exponential. So the first thing I'm going to do is I'm going to write, if you notice, our log form is always equal to y, and there is no equal sign. So I'm just going to put equals y's next to all of these because that's what we're actually solving for. We're trying to find what they equal. And just to keep it in the same form, I'm going to write equals y. Okay, so we're going to take the log form and turn it into exponential. So to do that, it says start with your x. Well, your x is the big number next to the log, so that's 8. So it's going to be 8 equals the base, which the base is 2, raised to the exponent of whatever's on the other side of the equal sign. So that's y. You can easily do this in your head, or you can use common bases. We know that 8 can be written as 2 to the third. So now that they both have a base of 2, I know that y has to equal 3. You could have also done that in your head probably. All right, the next one, take the big number next to the log, that's 16, equals, the base is 4, the exponent is what is missing, that is y. You can do this one very easily in your head, I hope. Y would turn out to be 2 because 4 squared is 16. The next one, the big number, is 625 equals the base, which is 5, raised to the exponent on the other side is y. This one also should not be too terrible to do in your head. You can start doing 5 times 5 times 5 until you get to 625. It is 4. So 5 times itself 4 times is 625. And the last one is 100,000. The base is 10 to some number y. It turns out to be 5. 10 times 10 times 10 times 10 times 10 is 100,000. And that is it for lesson 4.8. On to lesson 4.9. So 4.9 is dealing with the graphs of logarithms. And if you recall back from the last unit, the graphs of inverses are reflections, if you want to write reflections or a reflection, over y equals x. That is what the graph of the inverse will look like. Now, you know how to graph exponential functions. You just plug in your x values into the exponent spot, find the y's, and plot the points. So to graph logs, well, logs are inverses of the exponential functions. So you simply just switch the x with the y and plot those points. So if you ever have to graph a log, simply rewrite it in terms of the exponential form. So remember the x equals b to the y. And then switch your x with your y so you get your exponential function back. So let me just show you how that would look. So this would be x equals 3 to the y. Well, if you switch x with y, you get y equals 3 to the x, which is actually what is in the question. So you know they did it right. So the inverse of y equals 3 to the x is y equals the log base 3 of x. So to graph the log one, obviously you could use your calculator, but to do it by hand, you just graph the exponential functions. You're going to plug in all of these x's. You could plug in different x's, but these are the ones that are just there. So 3 to the negative 2 is really 1 over 3 to the positive 2, which is 1/9. 3 to the negative 1 is 1 over 3 to the first, so that's 1/3. Anything to the 0 is 1. 3 to the first is 3, and 3 squared is 9. So if you plot those points, so negative 2, 1/9 is really small, so just try to go, I probably should have even gone closer. Negative 1, 1/3, 0, 1, 1, 1, 2, 3, and 2, 9. 9 is the last one up here. Remember, they go on forever, so put an arrow, and then they're asymptotic to the x-axis. So it is getting closer to the x-axis, but remember, it'll never touch the x-axis. All right, so to do the log graph, which is the inverse of the exponential, you just switch the x with the y. So this is 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, and 9, 2. Now, you will notice when we graph this, so we're going to go over 1/9 down 2, over 1/3 down 1, over 1, 0, 2, 3, 1, and then 9, which is the last one, 2. You will notice, so this time it's asymptotic to the y-axis, and then it goes on forever in this direction. And if you were to graph, so I'll use a different color, the line y equals x, remember you go up 1 over 1, up 1 over 1, this will look like a reflection. It should look like you could reflect this graph over that line and get this graph. So that's how you know you did it right. If they are truly inverses of each other, they will be a reflection over the line y equals x. So now it says we are going to state the domain and the range for each function. And you already know what should happen, because with inverses, the x's and the y's, otherwise known as the domains and the ranges, they switch. So if you look at the exponential, by the way, I should have labeled these graphs. So this is y equals 3 to the x, and this is y equals log base 3 of x. So if you look at the domain of the exponential one, the domain, we can plug in any x in the entire world and we can get an output. So the domain is negative infinity to infinity, but the range is your y values. This graph will not ever reach 0 or go below it. So the range is from 0, and it won't touch it, so make sure it's a curved bracket, to infinity. Now let's look at the other graph. The domain, you cannot plug in every single x. Look at this graph. It will never go past the y-axis. So you can't plug in 0 or any of the negatives. So the domain goes from 0 to infinity, which you will notice was the old range. And the range is the y's. Well, look at this graph. It's going to keep going up, and it's going to keep going down forever. So the range is negative infinity to infinity, which again is the old domain. So that is a property of inverses that you should recall from the last unit. And then the last thing I just have to mention here is that all logarithms with bases larger than 1 are always increasing. They're always going up as long as the base is larger than 1. Same thing with exponentials, right? If the base was larger than 1, it was increasing. If it was smaller than 1 but bigger than 0, it was decreasing. So same thing. Logarithms with bases larger than 1 are always increasing. And that's it for lesson 4.9.